So it is Monday. It's lesson 11, and got a pretty good turnout for class on a Monday morning today. I know it's November, snowstorms coming. We don't have actually a lot of time left in the course. If we have a look, normally we would have 3 weeks after today, but because our semester, we're down a week, we're down to 2 weeks. So what are we going to do over the next few weeks? So this week, we're going to tackle unit testing. I'm also going to give you assignment 2, part 2. It's worth 10%. It's due on Sunday, but I have greatly scaled back the requirements. So normally we do 6 hours of unit testing lessons in class, and then you have a much bigger assignment for assignment 2, part 2. So I've reduced the size and the complexity of that assignment quite a bit for you. Okay, so it's due Sunday, but it's not a huge assignment. It's worth 10%. Then next week, we're going to have a simple lesson on building APIs with .NET Core. That's pretty simple. And then I'm also going to give you assignment 2C or part 3, and it'll be due the following week. It's smaller. It's only worth 5%. So you will not be spending hours and hours and hours on these 2 assignments. Okay, they're fairly small. And then our final exam is going to be in 2 weeks, week 13 during class time. I think I may have spoken about the final exam a little bit before. So with the exam, you'll come into the WebEx room. Oh yeah, that's fun. An exam for your birthday. And you will have from 11 o'clock until 2 o'clock to submit the exam. It's going to be all practical. So I'm going to provide you with the project, and then I'm going to ask you to make certain additions and changes to that project. So you won't have to set up a brand new project from the beginning. Hung, you're not impressed with that? What did you prefer? 800 multiple choice questions? And what I'm going to do is I will be randomizing it somewhat. So there's going to be a big list of requirements, and then each student is going to have to do a subset of those requirements. You won't have to do all of them. Yeah, I'm not going to make you build from scratch. In fact, just so you know, what we're actually going to do is I'm actually going to give you a working copy. You may have your own, but our starting project is going to be the video game shop. So we're going to work with the existing project because everybody's already familiar with it. We've been working with it every week for, by the time we get to next week, for 4 months. So what I'm going to have you do, there's lots of things I wanted to do with this application that we really didn't have time to do. So I'm going to ask you to add additional features on. Well, I won't tell you what those things are, but you could probably imagine if you go through it, you could probably look at certain areas of the site and see where either there's features that we could add or things that we did that maybe could be improved upon. So this is going to be our starting point, and the exam is going to be going further with it and doing some more things with it. But you do not have to use your own copy. I will provide a copy so that everybody is starting from the same place. There may also be, I might also put a couple of bugs in it that you will have to fix, potentially. Okay, so we'll do unit testing today. We'll look at building an API, a web API with .NET next week, which is very easy. And then our practical exam is in 2 weeks. So I want to just talk about assignment 2, part 2. I'm going to go over it. It's up on Blackboard. I have updated it. As I mentioned, I've scaled back what you are required to do for it. So it is due Sunday. A good time to actually do this assignment, if you don't have another class or don't have to run off to work after class today, is do it today. Well, because it's based on today's lesson, everything you need for the assignment we're going to cover in today's class. So while it's fresh in your mind, you could work on the assignment and work on 6 days, work on the assignment and get it done. Okay. So for part 2, all you need to do is just give me the GitHub link. You do not have to deploy part 2 to Azure because it involves unit testing and I need to run the unit test locally anyway. So you do not have to turn your Azure site on and deploy it. You don't even have to give me the Azure link. So just this, you can use the same repository you've been using all along. You do have to do your own work. You're not just copying what I do in class and changing the words and giving it back to me. You're doing your own and putting it in your own words. So here's what you have to do. You're going to take your assignment 2 and you are going to create a unit testing project in the solution. So we're going to do that in a minute in our video game store. And you're going to create a unit testing class for one of the controllers in your application. You don't have to do both of them. So your application has 2 or more controllers. You only have to do one. So let's say you've got, so Maggie, you've got a movie review site. What are the two controllers in your assignment? Is it movies and networks? Okay. So for Maggie's assignment, she only has to unit test one of the movies controller or the networks controller. She doesn't have to do both. So just pick one of your controllers. And then you're going to write unit tests for only one of the following methods in your controllers, right? So in the controllers we scaffolded, we have all of these methods: create, edit, delete. We also have index. We're going to write the unit test for index together in details today in class. So normally what I would have you do if we had a full semester is you would have to write unit tests for all 6 of these methods. And that's typically somewhere in the neighborhood of 3 to 4 tests for each method. I'm only asking you to pick one of them and write the 3 to 5 unit tests you need for one method only. So you can pick which method you want to write the unit tests for. I've given you a few hints here, and we'll look at these. These hints will make more sense from today's lesson. Okay, so in our methods, wherever they return a view, one of the things we're going to need to change is make sure we actually name what view we're returning. Create, details, delete. And if you choose one of the post methods, you'll also need to test what happens if we have an invalid model, and adding this line of code will let you simulate that process. If you're doing one of the get methods, you don't need this. And just make a minimum of 2 commits to GitHub, not just 1 commit at the end. So maybe get your project set up for unit testing and make a commit. Then write your 3 to 5 tests, make your second commit, submit your link on Blackboard, and you're done. I'm going to keep the assignment document up because we may need to come back and refer to it as we're going through the unit testing lesson. So basically, everything you're doing is based on today's lesson. So I'm also going to recommend, and I'll send out an announcement, that if you're working asynchronously, you probably don't want to wait until Sunday to do the lesson because you have to do the lesson and do your assignment on the same day. So I'd recommend do the lesson sooner rather than later. Okay, and it's due Sunday at 5 o'clock. So let's open up our store and in Visual Studio, and let's get it running. I've already got mine up and running. So we're not actually going to change anything in the front end of our application today. So our game shop is going to look the same. All we're going to try to do, and when we're adding unit testing, we're going to make sure we don't break the site. And that actually speaks to what unit testing is all about. So if you look here on, got a couple items as a bit of an overview for you here on Blackboard. So I'll let you read this. I won't read it to you, but what is unit testing? take a minute to read this description from Scott Guthrie, who's a longtime, a very prominent ASP.NET developer, writes a lot of documentation for Microsoft. Diana, that's a good question. We don't need to use the console because there are built-in testing tools right in Visual Studio that show us the test results. So we don't actually need to use the console. Yeah, Maggie, so that's exactly right. So the idea is that before we put our code into production, unit testing, it gives us a framework to let us try out all of the different things that happen in our application and make sure that the application behaves the way we want it to. So it helps in two ways. It helps us when we're creating new code. We want to be able to test it effectively before we launch it. But it also is really useful when we're updating an existing application, because one of the most common scenarios that developers face is we have a working application, and then later on, our client either discovers a bug or asks us to add a new feature to it. So then we have to go back to our code base and we start making changes. And one of the most common issues is we add our new feature, we fix our bug, but when we do that, we then break something else that used to work. And now we've got this problem. So if we undo the new changes, we can revert our code to the old one, but now the new work we've done is now gone. So the idea with unit testing is when we make changes, the unit testing allows us to run through all the original scenarios and make sure that all of the original code still behaves as we intended it to. So this saves us a ton of time and also helps ensure quality when we take an existing application and we add new features or we fix problems with it. It's helping to ensure we're not going and breaking with sort of unintended consequences where we're then breaking other things in the application. And this scenario is especially difficult when we're making updates far into the future. So we build a website, we launch it today, and it's up and running, we kind of forget about it, and then 6 months or a year from now, we have to go back and make changes. Well, now the code's not so fresh in our mind, and we may not understand how or why we did things initially. So the unit testing, again, it helps keep really clear for us what are all the expectations about how the program is supposed to work. So it helps us maintain and extend the lifetime of our application. We will look at that, Diana. We're primarily interested in unit testing controller methods. So a unit test is for one piece of code to test the behavior of a function or class. So for example, if we look at our, I'm going to close everything up here. Okay, so here's the orders controller that we scaffolded last week, right? We could log into the site. So if I logged in as a customer, I got an orders link. And if I clicked on it, it loaded the details for my orders. So it's calling the details method of the orders controller. So let's have a look at this method for a second. How many different things could happen in this method? And how many different things do you think we should test for? Tell me one possible scenario that you see in this method. What's one thing that could happen? Let's maybe look from top to bottom. Right, okay. Well, actually, let's come back to that one. So ID not found is one. There's even a scenario above that. What's happening in this scenario? Right, that the user is going to orders details, but there's no ID. So that would be this scenario. What should happen in that case? If we try to load the details view without any ID, what should our application do? Right, we can't fetch it because we don't know what order we're looking for. So this is one scenario here we'll want to test for. What happens if the details method is called and no ID is passed, right? So our method returns a 404 not found response. So we want to write a unit test that tries to call the details method with no ID being passed. And we want to check that the result we get back is a 404 error. Yes, potentially we could redirect as well, yes. So that's one scenario. So we would need a unit test for this condition. Now we come to the scenario Diana already outlined. We have an ID, but we have no order that matches that particular ID. So, I don't have an order for 1,000. So, in a way, we can actually see it here. I did actually get a 404, but yeah, it should show the, whoops, sorry, wrong console. So when I load this, it does actually return a 404 error. There's just not the proper error handling to display the page yet. But this is right. If I put in an order number that doesn't exist, I get 404. If I put in make a call, I get another 404 error. So those are two unit tests we would need. Number one, no ID parameter. Number two, we have an ID parameter, but that ID doesn't exist in the database. Okay. What other scenario could happen? So we get no ID, we get an ID, but that ID doesn't exist in the orders table. What other scenario could happen? Right, that we get an ID and that ID is found, and then we want to return the matching order. So if I put in a proper value, ID value, two things actually happen. One is it returns the proper order. What else could we check in the browser, right? So I get a 200 OK response in this case. So two things are actually happening here. Our order is returned. So that's another unit test. What else could we test for here? Yeah, we could test the access. And what about here? How could we test this? Or what should we be testing about the view? Well, we've got that here. We're checking that the right order is passed back. Well, we could check that the view isn't null, but I'm thinking we would want to be even more specific than that. Can we return any view back? Or do we have a specific result in mind in terms of what the view is? Okay, you're getting close, Maggie. Which view? So which view gets returned if the order is found? What's the name of the view that should be loaded? Right. Our view is called details. So if we have a valid ID, we actually can write two different tests. Number one, we want to make sure we get the matching order. And number two, we want to make sure that in the browser, our application is going to load the views, orders, details view. So we need to unit test this one method, we need 4 or 5 tests to check each individual thing that might happen. We don't want to check them all in one test, because if our test fails, we won't know which step didn't work. So we want to test each individual kind of path or scenario within the method. So we'll need 4 or 5 unit tests for this. So unit tests are designed to be very small. Okay, we do them one, so checking, did we get no ID? And if we had no ID, we return 404. That's one unit test on its own. So what we're going to do, it's there's a good resource here, even though this series is 5 years old. It's from Visual Studio Magazine, and they explain kind of how to do unit testing. Good question, Justin. You could, but unit testing is much faster. In a big application, for you to put a breakpoint and basically walk through every line of code one line at a time, it would be extremely time consuming to do. That's one reason. Whereas with the unit tests, just to show you, so I'll show you what the unit test, what this is going to look like kind of by the end of class today. So yes, you could put breakpoints everywhere and go through your code one method at a time. But when you write the unit tests, you can just run them all at once, and Visual Studio will tell you which tests passed and which tests failed, and any tests that don't pass, it'll tell you why they didn't pass. So we have this window here. So in the project, this is from my Tuesday class. So this class, this is my Lakehead section. They're a week ahead of us. So we kind of did this lesson. So I have 29 unit tests here for the products, for the 26 unit tests for the products controller. I can run them all with one click, and it will tell me each test. So for example, here was the test for details with no ID. So we want to invoke the details method with no ID, see what result comes back, and check that it loads an error. So it's much more efficient than using breakpoints. And this way, if we go and add new code to our application later, we can still just come back and run all our old unit tests to make sure that they all still pass and that our new code hasn't broken anything that was working before. In fact, there's also this strategy. If you look at this, we're not going to use this, but there's a tool called, or an approach called TDD that's actually described in this series. Has anybody heard of TDD before? Have any idea what it is? It's related to what we're talking about. We can do unit testing without TDD, but TDD is another approach to unit testing. You got it, Maggie, test-driven development. So what do you suppose test-driven development means? We are not doing test-driven development. It's too late for us. But many companies actually use test-driven development. So if you had to guess what it might mean, what do you think? Close, Diana. Maggie. You're close. Test-driven development. In test-driven development, we actually do this part first. Before we write any code in our application, we actually create all the unit tests. So we decide how should our application work and write all the unit tests for all the scenarios, and then we base all the code in the actual project on the scenarios identified in the unit tests. So you actually write the tests first, and then you build the app, you write the code. And your code, you make sure it follows all the rules of the tests. So we're not going to take that approach, but it's possible when the next few years, some of you are working, some of you are going to be working in places where that's how you build everything. You actually start by building your unit tests first. So what we want to do, yeah, that's right. And it helps us organize the code. Before we go and write a method, we've already planned out all the possible scenarios of that method. So we don't have to think through them. We're doing that thought process, that organizing during the test writing phase, which makes coding simpler and improves quality and reduces errors. So it's a very different way of thinking about code, but yeah, it's like a shortcut. So if we wanted to cover all of the methods in our, let's say, our orders controller, we would need tests, something like 3 to 5 tests. So the scenarios we just went through with details, we need to go through those scenarios for each one of these methods, basically. So I've given you a link here to our to the unit testing documentation. And we can start going through this. Okay, so we've got things running. So inside, I'm going to open up my Solution Explorer. And in my Solution Explorer, you'll notice it says one of one project. So right now in our solution, there's only one project, which is our web application. So what I'm going to do is I'm going to create a separate project inside the solution. So I'm going to right-click my solution, and I'm going to choose Add a New Project. Excuse me. And in my templates here, what I want to search for, Visual Studio supports a few different unit testing frameworks. We're going to use the base one, which is called MS Test. So just in the search box at the top, search for MS Test. And then it gives me a few options. There's MS Test C#, Visual Basic, and F#. So of course, we want the C# project. So search for MS Test at the top. And then the project type I want says MS Test, Test Project, .NET Core, using C#. So this project is only to hold our unit tests. There's no web pages. Right-click your solution and choose Add New Project. In the templates, search for MS Test with no space. And make sure you pick the C# version. And click Next. It wants to give it a name, so I'll just call it Get Me a Game Tests. You can call it anything. Yep, you should add it to GitHub. So I'll create. Actually, that's a good question. Do we need to add it? Yeah, it's already here. So now I've got this test project down here. No. Can we go with our own project? Farouk, I don't really recommend it. No, the idea is not to do the idea is to work together on the lesson, and then you take it on your own and try to apply it on your own in the assignment. So we get a project here, and it gives us a test class. So I'm going to rename this. It says unit test 1. So what I'm going to do is, let's look at my controllers for a minute. Okay. I'm going to right-click my unit test 1, and I'm going to rename it. And I'm going to name it to products controller test. So this file is going to hold all the unit tests to test all the methods in our web products controller. So it'll be the same name, just with the word test on the end. I'll hit enter. It will ask me if it also wants Visual Studio to rename the class here from unit test 1 to products controller test. So I'm going to say yes to that. Okay. Now, the other thing we need under our dependencies, we need to link the projects together, because our unit test project, we're using it to test the methods in our web project. But right now they don't see each other. So I'm going to right click on dependencies in my unit test project, and I'm going to choose add project reference. So this will link the two projects together, and it brings up reference manager, and I have a little checkbox here. There is only one other project in the solution. So I'm just going to check the box beside our Get Me a Game web project, and I'll click OK. So let's open up the products controller and let's look at what's here. Sorry, Farouk, I don't understand the question. What was what for? The whole purpose of this class is to write unit tests to test this class in the web project. Okay, Justin, because the using is one file at one class at a time, we're just going to make the dependencies at the project level. So the whole project is related. So anything in our unit test can see anything in our web project. So I'll save that. We'll go back to our product controller test. So let's take a look at our index file, for example. So what happens in our index method? So what happens here? We're querying the database to get a list of products and categories, and we load the index view, and we're passing in the list of products. So here's the page we're testing. I log in as an administrator. So we want to unit test this page. Make sure we get a list of products and the index view loads. So let's create a method here called index view is not null. So typically the names of our tests are descriptive. They describe, first of all, what method are we testing, and then what scenario, what result are we checking, and what are we expecting. So we expect if we call the index method of the products controller, we will get back some kind of view. It won't be null. It's not a very descriptive test. And unit tests, we basically have, unit tests is a three-step process. So here are the three steps we do in most unit tests. We have arrange, so set up what we need to execute the method we want to test. So any variables, etc. Our second step is act. Execute the method we want to test. Test and obtain a result. So in this case, the method we want to test is index. And the result we want to check for is that basically it returns something. And the last step in every unit test is called an assertion. Assert. So check if the result we got is the result we expected. So we would expect that the index method will return a view to us. So we can check that that's not null. So ultimately, we want to write unit tests that will always pass. So we can run them in Visual Studio so it'll look like this, like all our tests will be passing. That's the goal. So there's two tools here, the few tools Visual Studio has. It has this test explorer that lets us run and evaluate the result of every test. It also has this tool, which is sort of neat. I'll show you. So if I go to test and analyze code coverage, this shows us how much of the code in our application is covered by unit tests. And it shows us this in a few places. So I can open up my project. So in this class, we're building a beer store, is what the class voted for. And if I go into the controllers and my products controller, you'll notice it says my number of not covered blocks is 0. The percentage of code not covered by unit tests is 0. The percentage of covered code blocks is 100. And then it shows for each method what percentage of the method is covered by unit testing. It also does some color coding to be helpful. So if I go here, anywhere you see this blue highlighting, it means there is a unit test covering that section of the code. Anywhere there's red, we're missing the unit test. It now also shows, notice here in my details view, if I go to it, it says 4 of 4 passing. So Visual Studio says there are 4 unit tests in the solution now that are designed to test the code here, And each one of those, the last time it executed, each one of those tests passed. And it even shows me the names. So there's 4 unit tests in my project testing the different scenarios of the details method. So this helps us make sure that our testing is broad and that our code is actually covered by unit tests. So the first thing we want to do here, we want to now try to call our index method. Here's our index method. We do actually need a couple of different tests for this method. You know what? I'm just going to stop right here. Hang on just a second. We'll come back to the products controller in a minute. We're going to make something even simpler. We're going to make an empty controller and a view. Really simple. And we'll test that first, because the product controller testing is a little more complex. So we'll do an even simpler unit test first. So let's right-click our controllers and click Add Controller. And we're just going to pick an MVC controller empty. I'll give this a name of, let's see. I'll call it dummies controller.cs. So just create this dummies controller, and it's going to be empty. So in our dummies controller, all we have here is an index method that will return a view. There's no database connection. There's no other code. So all I want to do is make a dummies index view. Go to my Solution Explorer, under Views, I'll add a new folder called Dummies. And I'm just going to make an index view in here. So under Views and Dummies, we will add a view that's empty. And we'll just call the name index. It should default to index. And maybe I'll just put on just some text. So we're not working with the database. We're not doing anything new and complicated. We just made a new empty controller, and we made a new index view. So we'll try our first unit test, a really simple one at a really basic level, and then we'll take a break before we start testing the others. So in my unit testing project now, I'm going to make a new test controller. So I'll right-click my project, and I'll choose Add. I'll just create it as a class, a new class called Dummies Controller Test. We'll keep it very simple. So right-click the unit testing project, add a class, which is the Dummies Controller Test. So I'm going to add a few things here. I want to declare this as test class. And Visual Studio will give me an error. and it will ask me to make a reference to Microsoft.testtools.unit-testing. So I'll do that. I also need to make my class public. Excuse me. If our class isn't public, the unit tests can't run. And then we'll create our first test method here. So public, it'll be void. The test doesn't return anything. We'll call the text index. Why doesn't what happen automatically? Because classes are not public by default, Visual Studio doesn't know what we're doing with this class, so it's up to us to add that declaration for a test class. So we'll just call our test index return something. And then we'll set up our arrange, act, and assert. So to arrange, we need to create an instance of our dummies controller. Oh, I think we need this in here as well. I'm sorry. Public dummies. Sorry, here's the whole dummies controller class. I'll put it on paste bin. I missed this step. I'll put the link in the chat. So here's the dummies controller in your web project. I missed this, the constructor method. So we do need that. So this is our constructor method. So an instance of this class can be created. So now in our test, I want to create a new dummies controller. Not a dummies controller test, but a new dummies controller. And Visual Studio says, we don't know what the dummies controller is. So how do we fix it? We just reference the controllers in our web Get Me a Game project. So just add the missing reference. In the dummies controller. We'll take a break in a minute and I will push everything to GitHub as well in just a minute. So to act, we now want to call our controller index method. So this is going to execute, call the index method, and store the result that comes back. So now we want to check. All we want to check is that this result, whatever comes out is returned here, is not empty. It's not null. So we use the assert. And here are all the different assert statements we can use in our tests. That things are true, not null. The two things are the same or not equal. So we're going to assert.isNotNull our result. So if we call the index method, our test is saying something comes back. We don't know what it is yet, but something comes back. So we'll save that. And now we can run the unit test and see if it passes or fails. So up on the test menu in Visual Studio, I can click Run All Tests. Visual Studio is going to build the project, and then it's going to try to run our unit test. It'll tell us if it passes or fails. So it says my test run finished, 2 tests passed. And now I get a little green checkbox here. So I have this window here called Test Explorer. So our products controller test, well, that one passes because it's empty. Yeah, pretty easy. So now we've got a passing test. Now, it's not a very good test, is it? Because we don't know what is being returned. We just know something's being returned. So the test is passing, but it's not great. If we go and look at this method now, it tells us that we have 1 of 1 passing test here. So yeah, it's simple so far. If it seems easy, that's good. Wanted to start simple because we're going to get obviously more complex when we start working with data and checking different results. So this is like about the simplest unit test we could write. So what I'm going to do, I'm going to push this code up to GitHub in case you need help getting caught up. When we come back after a break, we're going to write a better test here. We'll keep this one, but we'll test for something more specific. Like, did we get back a view, and is that view called index? It's not enough to just say we got something back. Did we get the right kind of object back, and did we get the exact object we should get back? So we'll test those next, and then we'll come back to our products controller test. And we'll start to test some stuff in here. It's going to be a little more complex because we need a database for that, which adds complication. I'm going to push to GitHub. I'm going to stop the recording. Let's take a 10-minute break, and I'm going to encourage everybody, let's get up and stretch our legs a little bit. Okay, we will come back at 12:10.